Well, we notice but when we observe human behavior that people generally would rather have a certain amount of money for sure than to have a gamble that had an expected value of the same amount. So if you were to offer me a choice between $10 in hand and a gamble that would pay me 12 with 50% and 8 with 50%, expected value also 10. Generally speaking, we're going to see people choose the 10 for sure. We tend to be risk averse, and we see that over and over again. And our model of diminishing marginal utility, our utility, the relationship between utility and income, that's technically the word is concave, we actually, one of the consequences of that model, one of the reasons we use that model is that it predicts this risk aversion, or it illustrates this risk aversion. I wanted to just walk you through that. Let's suppose in this utility function, we have two possible states of income. One, if we're healthy, we have this high income, but two, if we're sick, we have this low income. We're not able to work as hard and we have to pay all these medical bills, so our ability to live is compromised. It turns out mathematically, I'm not going to show you the math, much to your mercy, that the expected value is a value that's found on this line segment between the point on your utility function that corresponds to the utility if you're sick, and the point that corresponds to the utility level if you're healthy. The utility level associated with the income level that results when you're healthy. Anyway, the expected value of the expected income, if these are the two states of the world, rests somewhere on this line segment. And where on this line segment the expected utility lies depends on the probability of the two states. If you're going to be healthy with 99% probability, actually the point on this line is going to be 99% of the way from this point to this point. On the other hand, if you're going to be sick with 99%, the expected utility associated with that state is going to end up your expected utility of that state would be right here. Anyway, so that's the point. Here we have point A associated with a situation where you're relatively likely to be healthy. That these probabilities refer to the probability of being sick. So A, you're probably going to be well, 75% chance you're going to be well. And here is B is a greater likelihood of being sick. Well, it turns out that we can develop a model quite easily of the demand for insurance out of this realization. Notice that the expected income of this gamble is given by E sub I, or E parentheses I. The expected utility is read off of this line segment. It turns out that there is some amount of income that we could have for sure that would provide us the same level of utility that gamble does. And notice that we'd be happy or equally happy. We'd have equally many utils. We'd be just as happy to have either be exposed to this gamble of being sick with probability 0.25 or being healthy. We'd be indifferent between that state or that gamble and this level of income for sure. Notice that this income for sure that we'd be happy with is a lot less than our expected income. So this is our willingness to pay for insurance. We have this expected income. we'd be willing to give up a lot of it to get this level of utility for sure. Now, in a competitive market, we'd expect insurers to be willing to provide insurance to us for a lot less than that, but that would define our maximum willingness to pay.